Now that we have completed the algorithm and pseudocode for the jump searching algorithm, in this video, let's quickly write the C++ implementation of the jump searching algorithm as well. So just like what we have done in the case of exponential searching algorithm, what we will do is here, we will create one more new file called jump searching.cpp. Okay, so the entire idea behind jump searching algorithm also will remain same as what we had in the case of exponential searching algorithm. First, the array of values, whatever we get, right, those array of values needs to be sorted either in the ascending order or in the descending order. Whatever the implementation that we do right now, right, this we are trying to implement it on an array of values in which all the values are sorted in the ascending order. Okay, so the steps that will involve in this jump searching algorithm are similar to what we have seen in the case of exponential searching algorithm, right, in which basically the very first step is to find the possible range in which the element that user wants to search might be available, and after that, in that specific range, we will be applying either binary searching algorithm or linear searching algorithm for finding the value. Okay, so that is the simple steps that are involved inside the jump searching algorithm or exponential searching algorithm. Now let's just quickly write it and validate the same thing. So first, let me just import all the boilerplate code that we would be needing, and here let me just include the vector as well. Okay, once we have this here, let's just add new class called jump searching. Okay, in this class, let me just create one public method. This method will basically return the position at which that value is available. If not, it will simply return -1, the exact pattern that we are following for implementing the previously implemented searching algorithms as well. So here, let me just define one function called jump searching, and this function will basically take array of values, and it will also take the value that needs to be searched in the array of values that we have been given. Okay, now the first step requires us to find the possible range of elements in the array that we have got in which this value is potentially available. Now for finding that range, if you compare this jump searching algorithm with the exponential searching algorithm, right, what we have done, we have defined one variable called range. We've initialized it with 1. If at all, if it is matching this condition, we are simply multiplying the range by 2, so that we will basically end up, the range variable will basically end up at the last index for the possible range that the value might be available in. Now, in the case of jump searching algorithm, what we will do is for finding that range, we will basically define the block size. So let's just define that block size. So in the beginning, the block size is equal to the square root of the number of elements that we have inside this array. So let me just write that specific logic. So square root of array dot size. So the square root basically comes from the CMath library, right? So let's just include that CMath library as well. Okay, after this, again it is showing error. Let's just try to find what is the error. Okay, anyway, there is nothing wrong. So we've got the block size. Now in this block size, the last index is nothing but block size -1, right? So let me just define the last index variable equal to the block size -1. Now what we need to do, we need to move this last index to the our possible range of values. That possible range's last index, we need to move this last index value to. So for that, what I will do is I will simply run one while loop. As long as this last index is less than the size of the array that we have got, array dot size, along with this, whatever the value we have at this last index, if it is less than whatever the value that user has passed, if so, what we will do is we will simply update this last index by last index plus the block size that we have here. So I will simply update last index equal to last index plus block size. Okay, in the case of exponential searching algorithm, we have multiplied by 2, but in the case of jump searching algorithm, we are simply updating that last index by last index plus block size. So that is the major difference that we have when we compare the jump searching algorithm with the exponential searching algorithm. Once this loop is completed, right, then this last index variable will basically hold the maximum index till we need to search. So we have the last index for the possible range. The beginning index for that possible range of values that we need to search is basically the last index minus block size plus 1. That will be the start index. So by using that start index and last index, it is completely up to us whether we want to employ the linear searching algorithm or binary searching algorithm to find the possible value that user has requested to search for. Now, in the case of exponential searching algorithm, we have already incorporated the binary searching algorithm, right? So here, let me just use the linear searching algorithm for finding the value in that specific range. So here, for that, what I will do is I will define one variable I. Here we need to start from the possible ranges start index. That is nothing but here we have the last index, right? This last index minus block size plus 1 will be the starting index for that range, and as long as this I is less than or equal to last index. And one more thing, remember that since we are adding the block size in this while loop, there is a chance that this last index could go beyond the size of the array that we have been given. So here one additional check that we need to do is, as long as I is less than the size of the array that we have got, in each and every step we need to increment I by 1. Okay, so that is the additional step that we need to remember here, checking this as long as I is less than array of size. Otherwise there is a possibility that you will try to compare this value with the value at this ith index, which is not available. As a result, it will basically cause the exceptions in our implementation. Anyway, now as part of the linear searching algorithm, what we will do, the value at the ith index is equal to the value that user has passed. If so, we will simply return I, because the position I has the value that user has requested. Okay, even after executing this for loop completely, if the value that user has passed is not available in the array of values that we have been given, right, in that case what we need to do outside this for loop, we need to return -1. Okay, so that's what we have returned. Okay, so let me just add the semicolon here. For testing, let me just copy paste the entire main method whatever we have written in the case of exponential searching algorithm, just to save some time. Okay, here instead of exponential searching, what we need to do, we need to create the object of jump searching. Let's just say the reference for is JS, and from this JS reference, let's call the jump searching algorithm. Let's just pass the array of values we have got, and the value that I want to search here is 1. Okay, now to execute this, let's just click on run code. Okay, so ideally 1 is available at index 0, right? So that is what we have got here on the console. Let's just say I want to search for the value 3. If at all I want to search for the value 3, 3 is available at index 2, right? So we should be getting 2. Okay, similarly, let's just search for the value which is not available in the array itself. Now if I pass -3, right, -3 is not available in the array of values that we have got. As a result, the output that we have got is -1. And one more check, let's just try to search for the value 8, which is available at index 7. That should be the output that we should see on the console. Okay, 7 is the thing that we are seeing on the console. Okay, so that basically validates the jump searching algorithm that we have discussed and written the pseudocode in the previous steps. Okay, remember that the entire idea behind jump searching algorithm and exponential searching algorithm will remain same. First, we need to find the possible range of values in which whatever the value that user is trying to search is available in. Once we find that range, we can either apply the binary searching algorithm or linear searching algorithm because the array of values that we have got are already sorted in the ascending order. Okay, so that's all for jump searching algorithm. Thanks for watching this one. I'll see you in the next interpolation searching algorithm implementation.